It is a media roundtable breakfast sponsored by the Science Coalition. We are surrounded by some of the most important leaders that you've never had a chance to meet in the United States. They are honorees of Presidential Early Career Awards for scientists and engineers, the highest honor bestowed by the U.S. government on science and engineering professionals in the early stages of their independent research careers. And all of you represent some of the best in the United States of America, so I want to personally congratulate you on this honor and thank you for being here today.
The detector for something called the Coronagraphic Planet Finder. This is a way to directly image planets around nearby stars. And if NASA pushes ahead with this, within 15 years, we could be taking images of Earth-like planets around nearby stars. So discovering another Earth.
In healthcare, I think being able to image into the body from the external without invasive techniques in 3 dimensions, in looking at tissue, I think we're on the cusp of an awful lot of good steps forward.
I would love to see a psychiatric patient who winds up in the psych ER, instead of being interviewed by a psychiatrist who asks him how he feels and whether he's been having any unusual thoughts for the last 6 months, instead put him in a scanner, get a number out and say, okay, you have this illness versus this one, this is the proper medication for you at this dosage.
Our dream is really to take the kind of data that she's talking about, this kind of scan data, model it in animal models to really understand how the circuits are connected that are underlying the functional differences that she can see in her scans in human patients, and then use neuroplasticity to learn how to resculpt how the brain is working, turn that back to psychiatrists to treat psychiatric diseases.
One of the things that we're doing right is continuing to fund basic curiosity-driven science. And the reason that's so essential is that the focus on basic research that's driven by curiosity and our desire to understand is the thing that has the greatest potential to lead to transformative discoveries. And it's through those transformative discoveries that new industries are created and entire new technologies are developed. And I think the funding of basic research through organizations like the National Science Foundation is a crucial role that the government plays.
I think consistency in research funding is very important. It allows scientists to focus on the research and less worry about scrambling to fund their research. What's great about the U.S. is we have one of the best university systems in the world. I think that's something we need to maintain moving forward.
Something that the United States does very well, I would say, is they really keep you thinking, okay, to sort of meet milestones every year, and it makes it for very I think, very energetic research.
There's another dimension to this, and that is the intellectual capital and people that we mentor. Maybe even more essential than the actual technology and the specific idea of our lab or our time. And that's one of the things that makes us distinct from other countries.
Really, besides money, the only other asset we have is people. So the people coming into our labs and their training that they have and their ability and motivation.
I study glaciers and ice sheets, and particularly their response to climate change. So of course the motivation for this study is sea level rise. So we need better Earth observation capacities, and right now one of the major things we need to know is how big are the ice sheets, how thick are they? And that's something we don't even really know for lots of parts of Greenland and Antarctica. And so it's very difficult to build a numerical model of how ice sheets are going to change if you don't even know how thick they are or what the substrate is underneath them.
I think every researcher is concerned about funding, and the typical life cycle of a principal investigator grant is 3 to 5 years, right? And so I work in a set of fields that are relatively basic, and so the funding scales are small enough for me to fund 1 or 2 graduate students in my lab for about 3 years. A PhD takes 5 years. We need to continue training our people to do that, and if there's sort of a sort of a roller coaster ride of funding, it really hampers our ability to maintain that position in the world.
I think we need to be developing young scientists to think of science as a field of exploration rather than as a field of memorization. When you reach the laboratory, as we all are entering young people, there's this wonderful moment where the student looks at you for the answer to something, and they realize that you don't know and they don't know.
The more that we are being personal and hands-on with our scientific world to young students, then the better.
The right metaphor for what we're doing is R&D. And if you stop investing in research and development, you very quickly cease to have any sort of leading edge in the world economy. If you really think that what we can compete on globally is innovation, then you'd have to start educating the scientists of tomorrow today, because there's a very long lag time.